think it's time to have the next session. And this is I really like the next topic because that it's not about how to use JavaFX to create boring business applications.
Hey.
Hey.
I work on boring stuff all the time.
That's
where the money is. Yeah.
It's not my fault.
But I find this also very exciting because I don't think we have ever had a JavaFX game talk at Code 1 or Java 1, right? I can't remember at least.
I don't think so. But the cool thing is, even for boring stuff, I mean, after this talk, Dirk, you are able to introduce little games in the next loading animations. How cool is that?
I should do that. Yeah, absolutely. Yeah.
Okay, but now the stage is all yours, Almas. I hope I say it right.
Okay.
The name. And yeah,
that's fine. Perfect.
JavaFX game development.
Okay. Hi, everyone. I'm Almas, and welcome to Modern JavaFX Game Development with Fxgl. Today, we'll look at some state-of-the-art things that you can do with JavaFX in terms of game development. And just briefly about me, in case you haven't met me before, I'm a senior lecturer in game development at the University of Brighton in the UK. My PhD is in computer science. In particular, it's visualization of Euler diagrams and graphs, data visualization essentially. I am the author and maintainer of the Fxgl game engine, which is what we're talking about today. And I've got a YouTube channel on JavaFX, Java, Kotlin, and a bunch of other things. And all these links will be at the very end of this talk. And let me know if you can see all that I'm showing you on the screen. And if something isn't clear, just let me know in the chat. I've got chat open. Right, so the outline is, we're going to do a bit of an intro to JavaFX game development. We'll mostly explore the Fxgl game engine in this talk, and we're going to look at various engine services. So what the engine can provide for you in terms of game development needs. And finally, there will be a few practical examples that you can follow in your own time, not necessarily as part of this talk, to build a small application. I've got a few assumptions. I assume that you know some Java 8 and higher, and you also have some JavaFX 8 to 15 knowledge. The API is more or less the same, so there haven't been many differences. And I don't assume any prior experience of game development. So anything to do with game dev, I'll be explaining from scratch. So here's a question to start us off. Can we make games with JavaFX? And I'm assuming the answer has been spoiled by the name of the title. Yes, we can, in fact, make games with JavaFX. If you Google around, you'll see a bunch of examples. Here are the two that I've picked, since it is likely that you've encountered them at some point. And so we can establish that we can make games with JavaFX. But there are caveats. I think we can all agree that JavaFX is a fantastic UI framework, but it is not a game development framework in itself. So it is not reasonable to expect game development concepts built into JavaFX. And in fact, in software development, we know that entities, libraries, frameworks should only do one thing, really. And so we have a lot of domain-specific boilerplate and concepts that need to be implemented when it comes to game development. And here are some examples below. We have logic, we have AI, gameplay, user interface, graphics, hardware. All these things need to be either implemented from scratch or adapted into the game development domain. We should also remember that JavaFX is a high-level framework. It doesn't allow us to do anything low level, primarily because we don't want to be doing any low level stuff. So these concepts that we can see need to be also implemented at a high level. And a straightforward answer to this problem, as it were, is to build something on JavaFX whilst utilizing high-level implementations of game development concepts. So here comes Fxgl. It's a high-level framework that aims to make JavaFX game development considerably easier. And all these screenshots you can see on the screen, these are parts of different games that were built with Fxgl. And here's a pitch, which is taken straight from the GitHub repository. There is no installation required. There's no setup that you need to perform. You simply add it as an external library and you're good to go. Maven, Gradle, or even Oberjar, any of these are fine. Plus, it's fully modular, which means that if you use the Java modular system, then you can still produce JLink native images of your games, which is awesome. And out of the box, Fxgl supports versions 8 to 15 of Java. I will note that the modular system is supported since Java 11 rather than 9. Windows, Mac, and Linux, well, that's kind of a given because JavaFX already supports those. In terms of Android and iOS, this is where we use Gluon client plugin. And web, JPro is a suitable tool that we can use, but more on that later. Subjectively, I will say that the API is simple and clean. Obviously, this will depend on how you view it, but it's definitely higher level than other engines. So if you want to play a sound, there's only going to be ever one method call. And the good news is it's a superset of JavaFX. That means if you know some JavaFX, you already know a great deal of how to use Fxgl. First of all, the UI API is exactly the same. You just use JavaFX without any changes. And I'll note here that Fxgl doesn't simply use JavaFX as an external library or a third-party library. It really integrates seamlessly with the JavaFX ecosystem, the architecture, the entire infrastructure. So for example, we use the same UI thread for modifying the scene graph. We use the same JavaFX event system, which is the same as the dispatcher. You have the going down and bubbling up events. In terms of background threads, it's your typical service/task API. And that's one of the reasons why Fxgl plays really well with other tech that potentially expects a JavaFX application, like Gluon Client and JPro. They were designed to work with JavaFX rather than Fxgl. But Fxgl is, because of its seamless integration, it just works, which is great. And we're going to look at various real-world game development techniques implemented by Fxgl in the next slides. And finally, games are easily packaged, either into a single executable jar or native images, depending on which one you prefer. So, what is it good for? Well, it's designed to be called from Java or Kotlin. The API is more or less unified. So regardless of what you use, you're going to end up with very similar API, which leverages the specifics of the language that you're going to use. The framework itself is developed in both Java and Kotlin. It started off as a pure Java framework, but then with Kotlin, certain stuff just got easier to implement. Any 2D genre should be fine to implement with Fxgl. There is no 3D support just yet, but there might be sometime in the future. We have complex UI controls, which is a courtesy of JavaFX. Because we're using JavaFX, it's really easy to build any complex UI controls. Hobby projects are fine. Academic environment has contacted me to say that they're using Fxgl for various courses that they teach. I certainly teach it at the University of Brighton as part of some of the courses related to game development and software development. And you can also use Fxgl for commercial projects. The license is MIT, so basically you can do whatever you want with the code and the thing that was produced by it. Here's the community in terms of academic institutions that have told me that they're using Fxgl for either teaching software development or game development. And if anyone out there would like to include a course that they teach, which also makes use of Fxgl, just let me know and I'll add you to the list. Right, so I've done the pitch, and hopefully at this point, you're wondering, how do I make a simple application with it? And here's the minimal example. It could be made even shorter if we get rid of these 3 lines, because these set up width and height and title, which are set up by default anyway. So most of the stuff you should be able to either deduce or know, because, public static void main, I'm pretty sure you've done that at some point before today. Launch is your standard JavaFX way of calling an application to start. So the only difference here is you don't extend an application, you extend a game application. And everything else is sort of very in the philosophy of JavaFX, shall we say. Here is a diagram showing the architecture of all the stuff that Fxgl has. And this was done about 2 years ago, so it doesn't include all the things that we currently have. Certainly not the 2 years in the past that we had. So you can see that there's quite a bunch of stuff inside of Fxgl and what Fxgl is capable of. And we're going to unwrap some of these in today's talk. How are you guys doing in the chat? Don't see anything new in there. I wonder if I'm still connected.
Yep, you're connected. Everything works fine.
Yep.
Everybody
Perfect.
is just watching.
Awesome. So there is a lot to unpack, and we're going to focus only on major topics and major systems. You can find all of the source code of Fxgl as well as games produced with it using these links. I will also attempt to copy paste this one into the chat. This should be the link to the Fxgl trailer. And let me know if the link works. It should give you an idea of how various systems in Fxgl come together. And looking at it at 60 FPS is much better than looking at sort of static image. Yeah, the GL in the title is game library. It used to be FX game library. They became a framework, but I kept the name anyway because FXGF kind of doesn't quite work. So what we have currently on screen is complex UI controls, which is, like I said, courtesy of JavaFX. So we can build quite complex things with not only the stuff that Fxgl provides, but also with just plain JavaFX within Fxgl. And this is an example from Card Combat. And all the games, by the way, that will be screenshot displayed in the talk are available from the Fxgl games repository. And here's what we have for the animation system and interpolations. We can define an animation as a change of some value t over time, and that t could be anything. It could be an integer, a double, a color, or even a string. So anything that can be animated over time can be represented as a Fxgl animation. And here is the Fluent API that you would use in order to play an animation. You don't necessarily need to memorize any of the API shown here. These are just to demonstrate what kind of things we can support in Fxgl and how you might go about calling the API. So interpolators are the rate of an animation change. So it tells you how fast something needs to move or how slowly it needs to move, but it'll still move over the duration of 2 seconds. The asset management is unified in Fxgl. That means there is a standardized directory structure. So if you put all your assets into the assets directory, you can then place your sound effects and MP3 files under music, PNG, JPEG, and any other images that JavaFX can load into textures. And there are also other specific types that you can have under UI fonts, UI CSS, and so on. And you can load all of these things with just saying, get asset loader service, and then load one of these things, which is great, because you have a sort of unified form in terms of the API. There is a significant amount of DSL provided in Fxgl. So you can, for example, call something like set to create a variable from anywhere in your code. Although these are global in a sense, if you look at them from the perspective of you can create and call your variables anywhere in your project, but they're not global in terms of the language level. And the great thing about these global variables is they're backed up by JavaFX properties, JavaFX observable properties. So if you have, for example, your integer property and you've created myInt as your variable, you can listen for changes in that variable. You can also bind to the variable itself, which means you have one variable which simply duplicates the value of a different variable. You'll find this very familiar because that's the event bus that we use in JavaFX. Or something very similar. We add an event handler, we say what type of event we're listening for, and we then add the handler itself, which is a Lambda callback. And you'll find that a lot of the Fxgl API uses callbacks for various things. And once you've added the listener, you can just fire the event, and then the event will go through the chain of the JavaFX event dispatcher, and will give you the event that you need to handle here. Now, this relates to input bindings. In terms of input, there is a range of things that we accept in Fxgl. So it could be a keyboard key press, it could be a mouse button, it could be an Xbox One or a PS4 controller, for example. Well, I guess at this point we have Xbox One S and or Series S rather, and PS5, but we'll get to that. You can even accept touch events on mobile, for example. So there's a bunch of stuff that can be recognized as a trigger, and an input is going to bind a user action to trigger. And yeah, because it's built for the JVM, it runs where Java runs. So unless we have something like JVM on a console, we won't be able to run it on a console. And going back to the DSL, domain-specific language, what we have is, so going back to the slide, this is the full API. and it can be shortened to this DSL API. And obviously, you can just get rid of the other callbacks if you don't need them. Native images, yes, native images are fine. Okay, in terms of dialogues, this is your typical way of creating a user interface widget / object to say to the user something has happened. So here is a message box that you can utilize to do that. You can use a confirmation box, which is a different type of dialogue. There is an input box that you can use to get some input from the user. And finally, there is a customizable box where you can put any JavaFX node. In terms of background tasks or any heavy tasks that we can utilize, there is an API called IO task, which wraps a piece of code that can potentially fail. And by fail, we mean through an exception. And this is actually a simplified version of what pretty much is in the Fxgl source code, which starts the main loop. So we're wrapping init services call into an IO task because potentially one of the services can fail during initialization. And on success, we do something in terms of well, starting the loop. And if something fails, then we say handle fatal error because we could not start the main loop and therefore we just need to do something. These IO tasks can also be run in multi-threaded mode. So you may want to run something in the background, whereas the result is then thrown to the JavaFX UI thread. And this should be very familiar to you because the task API is what JavaFX uses anyway. You can run callbacks on sort of various threads, on a background thread, on a JavaFX thread. You can even block the UI with a dialog saying, here you go, we're doing something like a network connection. The game cannot be played just yet, so we're going to show a dialog. And here are a few examples where this could make sense. So Pac-Man or Outrun, these feature some AI, which means you can run your AI in a background thread, and then the result could come back on the UI thread to modify the scene graph. On to localization now. So how do we localize things? There are two ways of doing that. You can either read from a .lang file, which is a key value plain text file that you load, or you can create mappings dynamically. So you get the reference to localization service, and then you say, I'm going to add language data for a specific language. And then you provide a map of key value pairs. And again, great thing about that is properties. We still come back to JavaFX properties. So any localized key is going to give you a value as a property to which you can bind. In other words, if you have a UI, you can bind all of your text to these localized properties so that when you change the language, the UI changes automatically. And do note the title of this menu, by the way. Shout out to JFX Days organizers. So this is a custom menu, which you can build with Fxgl, and it will give you the stock parts to it, like the your standard options, gameplay, controls, video, audio, And you can see the controls area here on the right that you can also rebind at runtime, as in when the game is running. And you can either continue using stock menus, or you can modify stock menus using this reasonably straightforward API with factories. Essentially, you're saying, I'm going to set my own scene factory, and when called, it's going to provide your own specific menu where you can add anything you want. And here's a custom menu built for the game Undead Allies. Right, onto networking now. The API is, again, high level. That's the whole sort of philosophy behind Fxgl's API. The first 2 lines of code allow us to create a server object using the given port and start the server. The other lines allow us to create a client in a very similar way and connect to the server. All of the major functionalities are covered by callbacks. So here you can say set on connected and then pass the callback. The callback will be executed when a connection occurs. And then you can say, well, using that connection, I'd like to handle all the messages that come from that connection on the JavaFX thread. Because you probably want to modify the scene graph in some way. And all of the API allows you to also write these or make these calls asynchronously. This is something I'm quite pleased about, the particle system in Fxgl, which is highly customizable. So here is an example of a static image. And if you've watched the YouTube video, then you've seen it in action, and it just looks great. And here are the ways you can modify or configure your particle system. You obtain an emitter, or you can create your own one. And then you can add a bunch of config calls saying, I want to use the source image as a single particle. I want to change number of particles per frame or per emission. And you can then as well specify various scaling function, expire functions. You can change where each particle is spawned. So there are various things you can sort of apply. In terms of profiling, it's been updated, and this is a modern look of profiling in Fxgl. When you run your game with profiling enabled, you're going to get 3 different windows up, and each one is going to show you slightly different stats. The first one on the left is FPS, how many frames JavaFX is rendering. CPU is the next one that tells you how many, how long or the amount of time taken to compute the last frame by the CPU. And finally, the third window is going to tell you how much RAM your game is eating. And you can see the big drop there is the garbage collection kicking in. At the end of the run, the profiler that you enabled will show you some stats, so you can sort of fine-tune your game as needed to run potentially at 60 or even higher FPS. Your monitor allows you to run at higher refresh rates. So now this nicely brings us to rendering. This is a screenshot from the Zephyria RPG game. And one of the test maps has a dimension 500 by 500. So if we multiply that by the tile size, we get an image which is 16K by 16K. And because the viewport is only 720p, we want to be able to draw a 16K image, or rather a portion of it. If we just use the viewport provided by ImageView class, we may get some rendering artifacts. At least I got some rendering artifacts when testing it. So I need a way to extract a 720p image from a 16K image. And this is being done in Fxgl every frame and still running at 60 FPS. So really kudos to JavaFX rendering. It's great. I mean, this is running at 60 FPS without any performance optimizations. Just sending a bunch of stuff to the GPU through JavaFX API. So it'd be really great to hear some thoughts and feedback on how we can improve or optimize rendering in JavaFX. In terms of serialization, if you wanted to save your data, so your game data, so they can load it back at a later time, you have the bundle data structure. It's like a map, so it maps keys to values, and all values need to be serializable, as in Java.io serializable. So essentially, there is no separate serialization built in just yet, and I've kept using the standard reflection that JVM provides. So this will potentially change in the future because we don't really need to save a lot of stuff that we don't, things like metadata that is provided by JVM. But the API is something like this. You are given a data file and you put all your stuff into a bundle, put the bundle into the data file, and then that's it. Everything else is handled for you by the Fxgl. Similarly, when you're loading, you're given a data file from which you can obtain your bundle. But like I said, serialization might change in the future. Playing audio is relatively straightforward. You have the DSL calls, so you can say, just play. It's much more concise. It's what the common use case is about. But there are not many things you can change with that, so it's not flexible. If you want the flexible approach, then you do it the full API way, the long way. You actually load the sound, you're given a sound object, you can then configure that object, and you can play the sound using the audio player. So a few different ways of doing the same thing, pretty much. One is more flexible than the other. In terms of mobile, Fxgl wraps Gluon attach, the Gluon attach project API, so that users will only need to work with the Fxgl API. So you don't need to know, for example, how to access the file system. It's all going to be going through the Fxgl API and then calling attach API, which in itself simplifies a lot of the platform-specific stuff. Similarly, things like audio and anything else that is platform-specific will be handled by Fxgl, which means that's the only API you need to know. And this is a screenshot, well, this is an example of Breakout running on Android 10. Now, if you wanted to use a controller, like Xbox One controller, for example, then you simply add an extra parameter to your input API saying, well, remember that key code F that I wanted to press to make this action happen? Well, add a virtual button to it. And that virtual button gets translated to either actual hardware, as in controller, or your touchscreen virtual button. Because on mobile, you don't have a keyboard or a controller. So the touchscreen sort of emulated, or what's the word, virtual controller will be created for you. So you can actually press the button on the screen. And you can also obtain some information from the hardware, like left stick, right stick, right, left triggers, bumpers, and so on. Now onto the tools now. Various tools supported or built with Fxgl. This is a dialog editor, and it shows an example of a dialog graph. You can build multi-branch dialogues. You can build scripts into that. For example, a character is in an RPG game is a healer. They can heal you for some money or for some gold. So when the dialogue branches to that function, when you're asking your NPC in the game to heal you, they might call a function, and that function can be added inside the editor. You're just saying in the function, you need to provide which actual in-game function you want to call, and you provide the name of that function as well as the parameters. And then using reflection, Fxgl will find that function in your game code and will call it. And there are also choice nodes. There are various different nodes that you can have with this dialog, which was released just recently. And the link is also available on the Fxgl repository. It's under releases. And you can also run the dialogues inside the editor. So if you wanted to just playtest your dialog that you've just created. Yes, this PDF will be made available publicly. Onto the entity component model now. So this is the core architecture of Fxgl related to game objects. So a game object in Fxgl is called an entity. And everything, pretty much everything that you can see on the screen is an entity. So the spaceship, the bullets, the grid, the enemies, the whatever this thing is, crystals, all these things are entities. You can think of an entity as a Java object that has no fields. And this is an example from Geometry Wars. So if everything is just a plain object with no fields, then how do we distinguish, for example, between a bullet and a crystal? Well, this is where components come in. And this is the architecture that many popular games follow as well, such as Unity, Unreal Engine. They call it slightly differently. For example, in Unreal, it will be called actor and then component. In Unity, it's game object, also component. And in Fxgl, components hold data and behavior. So using components, you can define what an entity is. Here's an example of a very simple component called position. And we can store, for example, X and Y values, again, as JavaFX properties, which means we can bind to them, we can listen for changes, and we could add methods such as move. So here's the sort of main difference versus your typical object-oriented approach for building software. Everything is an entity, so there is no sort of vertical hierarchical structure. Everything is horizontal, which means there are no subtypes, there are no supertypes. And components hold data and behavior for each entity. If entities are objects, then components are your fields and methods. So imagine being able to construct an object and add components as in fields and methods at one time. So it's almost like JavaScript, I suppose, but much more type safe. Here's an example. You create an entity, add a position component, and now your entity knows about its position. Before that, it didn't know anything. You can add WASD input component, for example, and then you're able to move your entity using WASD keys. And with this great power, as we all know, comes singular responsibility and loose coupling as well, which also means that each component is only responsible for one thing. So you have a position component, it stores data about its position and can perform some methods that change that position data. That's it. So we can mix and match components at runtime. There's no need to worry about, say, compatibility, because they're, you have the single responsibility thing there. Components mostly change only the data that they hold themselves, and they do not change any public data. So you have your standard encapsulation going. And because these are backed up by bindings, you can, use your standard JavaFX properties and so on. Yep, 5 minutes, that's fine. I'll skip through some of these or go through them a bit quicker. We have bounding box and SAT checks for collision detection. This is the lightweight. And bounding shapes are the ones that you can see in developer mode. So the red boxes tell you what the bounding boxes are of each entity. And there's also heavyweight physics, which is supported by the JBox2D library, which is integrated into Fxgl. This is where you say the physics will now be controlled by the physics world and its simulation. So you can no longer change values of X and Y, for example, directly. You need to actually physically apply force to an entity to move it. In terms of drawing, you just say new view component, or with a rectangle, which is software generated shape, or a texture if you want an image. All these post-render effects are baked, as in blend modes and things like that are of zero cost. So there is no time spent on computing this thing when rendering. They can be baked if needed. But if you need something like dynamic blending, then you'll still use JavaFX's blend mode. There is also AI built in for some of this stuff, like pathfinding. There is the A-star algorithm implementation, which is, again, another component. You just add it to an entity and then say which cell you want to move it to. There is tiled map editor support. So you can, on the right-hand side, you can build your levels, maps using the tiled map editor, which is quite popular. And then on the left, you can see an example of loading it into the game and what it looks like in the game. I'll skip this because it just tells you how to do this. Here's an example of a tiled map level, which is a bit more complex, that combines both static and dynamic entities from undead allies. And I'll briefly go through your standard basic example that you might do. So this is one of the practical examples. We already covered initialize settings and main, and the only new thing here is that you create an entity builder, and then you say, I want this view for an entity, and build and attach. Build will create your entity, attach will attach it to the game world. Step 2, get a player reference. So the only thing changed here is we got the entity reference here. Step 3 is input. On key down, key code W, which basically says when this thing is pressed, I want to run this bit of code. Translate is your standard JavaFX term, means move. So you can move your entity using WASD. You can create a component, and that component is going to rotate our entity by 90 degrees per second. And we can also add that component when constructing our entity. Perfect. Last slide. JavaFX cross-platform game development is very possible, and I hope I've demonstrated that with the Fxgl game engine. And Fxgl makes the development easier and more robust by providing access to real-world tools and techniques. So it doesn't come up with anything new per se, It makes use of concepts that are well established in game development. If you want to contribute, you can using a variety of ways. You can crash test features, you can create an issue, provide an implementation for an issue, you can sponsor the project starting at $1 a month, and you can cancel anytime. You can proofread wiki for errors, and you can also start their project repository, which is the easiest thing to do. Thank you for listening to me talk for 45 minutes. And here are some links that you may wish to follow, particularly GitHub, where you can find Fxgl source code. And any questions?
Yeah, so we have several questions. But first of all, thanks for the great session. So one question that came up, and I had the same question. So if this was not coming from the audience, I would have asked that. So what we've seen here is great, but as some said, okay, this is for development of games. But I assume that this could be used quite nicely to develop more complex graphical applications like map editors, CAD editors, things like that. You've shown the example of the message dialogue editor, and I assume that one is written in Fxgl2, or?
It's written, it uses Fxgl, yeah. It uses Fxgl 11.
Okay. So it can be easily used to not only write games, but write like business applications too.
Yeah, I mean, Fxgl is built directly on top of JavaFX. So you can build any application that you want with Fxgl. It doesn't have to be a game. You just get access to game development tools if you wanted to. But you can still make use of the entire animation system, for example, which I assume is going to be very handy in running anything that looks super nice in the UI. Like all these, for example, bounce, exponential, all these easing functions, or tweening they're called as well, interpolations are heavily used in any kind of UI application. So yeah.
But aren't those all running on Canvas API, or are you also using Scene Graph API? Because there was another question in the chat.
It takes a node, and it can then animate either the node, or you can animate just values, raw values, as in you can provide X and Y as doubles or double properties, animate them, and from that perspective, it doesn't really care where you use it in the back end. You could use Canvas API or Scene Graph or anything, or something different.
Okay. Okay. And yeah, so the next question is a little more deep in that area. So the question here was if it can be embedded in Swing in a JFX panel, for example, and if internally double buffering is used.
Double buffering is used in the Zephyria RPG example. That was double buffered because single buffering produced some weird rendering artifacts. So double buffering, yes. In terms of Swing, the JavaFX scene that's used has a root, which I'm assuming you can take and embed into a Swing parent, because I'm not familiar with Swing nodes. I know there's a class there that kind of acts as a bridge between JavaFX and Swing.
Yeah, that's the class that was mentioned here, the JFX panel. Yeah.
So as long as it's a parent and it accepts a JavaFX node, then I'm assuming you can take the root from the Fxgl scene and just put it inside the Swing node. That would be my guess, but I don't have any experience in that area.
Yeah. Okay. VR. Do you plan to support VR or HR in future?
Virtual reality. You mean by VR? I don't know. I've never really used any APIs to go with it.
Okay.
But I guess before you can do anything VR related, 3D support needs to be enabled, I assume.
Yeah.
In which case, we need to figure out the requirements for 3D first. I've given it some thought, and I think the only things that will need to be adapted are the physics engine, because currently physics engine is for 2D, and the rendering itself. Apart from that, everything else, like file systems, audio system, animations, all these are just services that can work with anything, really.
Nice. That sounds good.
I think for the purpose of gamification of business applications, and I think I talked to you about that once before, but
about the achievement system, which I didn't talk about today, but it can be used separately as well because it's fully modular. In fact, I'm running.
So there is one. You have an achievement you can unlock achievements and define.
I don't know if you can still see my screen.
Yeah, we see it. That's fine. We can see it.
Yeah, there is Fxgl achievement module, which is completely separate. So you can actually depend on that separately from the engine.
Modules.
Right.
So we are running out of time. So maybe two last questions. So one is, this was quite early at the beginning of your talk. If you have like templates for different game types. So is there an FX template for like a Zelda kind of game, a Mario kind of game, a Tetris template, something like that? Do you have such templates?
Yeah, that would be the link which I can copy paste into the chat.
Okay.
There we go. The Fxgl games. It's currently loading in my browser. I have a very poor internet connection.
Yeah. Okay.
So,
but we have that's great.
Yeah, and that link will lead you to all the source code for templates of different types of games in terms of genre. You have your platformer, you have your sort of arcade type, and so on.
Yeah. So sadly, we're running out of time. But I assume after the session in the near future, you will be booked a lot of times to add particular effects to boring business applications.
That is fine. Yeah, keep them coming.
Okay. So thanks for having you. That was a totally interesting, great session. I'm just looking.
Thank you. Thank you for putting all this together.
Sure.